So why do we need parameters at all? Say I have the set of parametric equations, x equals 5t and y equals 5t. Well, what we can do is just write x equals y. Isn't that more simple, less complexity, more easy to describe and talk about to other people? Why do we have to say x equals 5t, y equals 5t when we can just say x equals y? Well, here's the reason. So today I'm going to explain this in my video. Why do we need a parameter? And let's look at the real life example. So this is my made up 7-day sales figure for ice creams and sodas at the beach in a sunny, warm summer. So on the first day I have 6 and 216. On the second day I have 0, 0. We have 1, 1, 464, 5, 125, 3, 27, and 2, 8. Now, obviously, you can see a pattern really quickly. You know that. So firstly, before we talk about the obvious pattern, we know that when the sales of the soda decrease, the sales of the ice creams also decrease, right? When the sales of the ice creams increase, the sales of the sodas also increase. The trend of the sales of ice creams and sodas are the same. And the secondly is the obvious pattern. So let's let I be the sales of the ice creams on any day. So I to the power of 3 is going to be s. S is the sales of sodas. Isn't that obvious? So in this case, we have no parameters, right? If we were to graph this I cubed equals s thing, we would have s, I, and then it would probably look something like, I don't know, something like that. Probably like a curve going upwards really fast. So we have I to the power of 3 equals s. However, we know that this is, well, logically, not true, because it's logically not true because no rule says that if I buy ice creams, then I've got to buy sodas, right? No one says that. No one also says if I don't buy sodas, then I have to decrease the sales for ice creams too. No one says that too. There are no rules made up for who wants to buy what, and you can just buy whatever you want. It's just a normal shop in the beach. So we have to introduce a parameter. So what a parameter is basically the fundamental relationship, the fundamental cause of the sales of the ice cream and sodas to increase as one increases and decrease as one decreases. So let's just extend this table a bit, and we have this thing here called let's call it temperature. Okay, and Celsius degrees. So on the first day, let's just make up some data to fit this description. So on the first day we have 32 degrees, and then on the second day the weather, so it was raining, right? So it's raining, so it's only 22 degrees and it's raining. So on the third day it's 25 degrees. On the fourth day it's 27 degrees. On the fifth day it's 28 degrees. On the sixth day it's 26 degrees, and on the seventh day it's 24 degrees. So there is a somewhat pattern here. Actually, let me just change the last one to 26 degrees. There is a somewhat pattern here for the temperature. When the temperature increases, the sales increase. When the temperature decreases, the sales decrease, right? Well, that's the kind of rough trend there, the general trend we can figure out. And in fact, the temperature actually affects both the ice cream and soda sales. Say it suddenly turned 0 degrees in the middle of summer, then no one would bother even to go out to the beach, right? So there would be 0 sales for ice creams and sodas. It's not like there's a rule saying, I don't want to buy sodas today, so I'm not buying ice creams either. It's because temperature affects both. And since temperature affects both of these variables in the same way, it's a parameter. It's the fundamental cause. So let me just write that, fundamental. So it's the fundamental cause of the two variables to change. And since the fundamental cause, our parameter, affects the two variables in the same ways, so the two variables have the same trend, right? So that just makes logical sense now. The temperature affects the sales of ice creams. The temperature affects the sales of sodas at the beach. So this just makes logical sense. So parameters are a tool that help us make logical sense. Because if I just said that I cubed is equal to s, that obviously that's mathematically correct, and it's really easy to figure out the trend like that. However, it's not making logical sense, because no one says that the ice creams have to have the same trend as the sodas. No one says that if the sodas don't have cells, the ice creams can't have cells. It's just that the temperature is a fundamental cause, and it affects both of these cells in the same way, such that they look like the cells affect each other themselves. So the parameter makes this logical sense. So that's the point of a parameter. And basically here, we can also have another example of a parameter used in math. So believe it or not, we've already been using parameters for a long time. So this example here is about the unit circle. So the unit circle is basically this. So the circle here with a radius 1 on the xy coordinate Cartesian plane. Right, so I have this, and then I have 1, negative 1, 1, negative 1. And if I just drew a circle with radius 1, that's my unit circle. And what's special about this unit circle? So if I had this angle here, theta, then my coordinate point here would be cosine theta, sine theta, right? We all know that. So this replaces our SOHCAHTOA way of figuring out sine and cosine values. This is the new way of figuring out sine and cosine values. You take this angle here, and you figure out the coordinates, and you figure out the cosine and sine values for this coordinate. So you've already figured out the sine and cosine values for this theta angle. So in this case, you can write x is equal to cosine theta, and y is equal to sine theta. Well, that's not false, right? For every single point here, for any theta, the coordinates are cosine theta and sine theta. So in this case, theta is actually our parameter. It's the third variable we introduce to describe both x and y. And it connects x and y together. However, we could have also written this equation of a circle as x squared plus y squared equals 1. That makes sense either, right? So we have that the distance between the origin and this point here is 1, because that's the radius. So which way is more convenient? Well, if you were looking at the circle, you'd say this way is more convenient because you could modify it easily. However, right now we're looking at the angle theta and how the angle theta affects x and y. How every time we have a different angle theta, we have a different x and y. Therefore, here theta is more logical when we're looking at the angle instead of the distance between the center and any point on the circle. So theta is our parameter in this case, and it helps us connect x and y together and helps us understand the unit circle. We've been using this parameter all along, we've just never noticed. Another significant parameter is time, or what we represent as t. So t is also a parameter. So how is this parameter used? Say I had this 1D motion here. So I'm moving along this line, or let's say there's a car here that's moving along this line. That makes more sense. So my car is moving along the line. I don't have a car, but okay. So the car is moving along this line, and it's moving at 5 meters per second velocity, right? So that means that 2 seconds later, it will be here at a 10 meters away from its original position. So that's our new car position. So in this case, we have two variables here. So we have our velocity and time. Actually, we have our velocity and our position. And we also have time. So velocity and position seem to relate to each other, right? I mean, they do, don't they? So position is basically displacement, is basically velocity times time. So they obviously relate to each other, and the velocity significantly affects the position. say if I were moving at 0 meters per second, I'd never get to the position with 10 meters, right? Because I'm not even moving. If I were moving 5 meters per second at a constant speed, I'd take 2 seconds to get to the 10 meter position. If I were moving 5 meters per second in the first second and I accelerated to 10 meters per second in the second, then I'd take a different time to get to 10 meters away from my position. So velocity and displacement or position obviously affect each other, and they affect each other in really obvious ways. However, what both affects velocity and position is time. So if I have an equation for velocity related to time, so we can say velocity is the final velocity is the initial velocity plus acceleration times time. So if you're not sure about this equation, check my previous video. It's about the big 5 kinematic equations, and I proved this equation in that video. So a is acceleration. It's the rate in which my velocity increases, right? So as my time increases, my velocity will also increase, assuming the acceleration is a constant, right? So my velocity is related to time. Now, what about my x position? My x position is obviously also related to time, because it's basically so delta x, change in position or change in displacement, is basically equal to 1/2 times vi plus vf times t. So this is just the average of the starting and ending velocities. You can also watch my video about the big 5 kinematic equations. So this is obviously related to time as well. So assuming that we know these variables here, vi, a, 1/2 vi plus vf, time here is a parameter, and we can plug any value in for time and get what we want. Well, any value for time that is larger or equal to 0. So in this case, time is a parameter, and in physics and science and kinematics, time is the most common parameter out of all. So it's important that we understand why parameters are needed. It's because, so let me just summarize today's lesson. It's because they help us make sense of things in the logical way. So mathematically, things without parameters are more simple, right? With more simplicity, less complexity. And they probably make more sense when you try to graph them and describe them to other people. However, when you understand why the two variables relate to one another, the parameter is a fundamental cause that helps us understand what exactly causes the two variables, to have the same trends.